Have you ever wondered how a computer can recognize a face, or how your phone knows what you're going to type next? Welcome to the intriguing world of artificial intelligence, or AI for short. This isn't science fiction, it's our current reality. AI is everywhere. It's in our phones, our computers, and even in our cars, quietly transforming our world in the most extraordinary ways. It's making technology smarter, more intuitive, and more capable of understanding and responding to our needs. This is not just about machines doing tasks faster and more accurately. It's about systems that can learn and adapt, that can understand and even anticipate our needs. It's about creating interactive experiences that feel natural and human. The secret behind all these impressive feats is something called a neural network. So what exactly is a neural network? Well, think of a neural network as a digital mimicry of the human brain. Just as our brains are composed of billions of neurons that process and transmit information, a neural network consists of interconnected nodes, or neurons, that work together to analyze data and make decisions. Now, don't fret. This isn't as complicated as it sounds. Imagine you're trying to recognize a friend in a crowd. Your brain doesn't just look at the color of their hair or the shape of their nose. It takes in the whole picture and processes many different features at once. That's essentially what a neural network does. It takes in an array of data, processes it through multiple layers of these artificial neurons, and produces an output, like identifying your friend in that crowd. But here's the truly fascinating part. Just like us, neural networks learn from experience. They start knowing nothing, a blank slate. As they are exposed to more and more data, they begin to understand patterns and improve their performance. This is known as training the network. For instance, if you're training a network to recognize cats, you'll feed it lots of images of cats. Over time, it will get better at identifying what makes a cat a cat. And just as we learn from our mistakes, neural networks do too. If the network incorrectly identifies a dog as a cat, it will adjust its internal parameters or weights to reduce the chance of making the same mistake in the future. This process, known as backpropagation, is akin to the trial and error learning we humans do. We're just scratching the surface here, but hopefully, this gives you a basic understanding of what a neural network is and how it works. It's not some mystical entity, it's simply a complex pattern recognition system, designed to emulate the way we humans learn and process information. In essence, neural networks are the brain of a machine, learning and improving just like we do. Neural networks might sound complex, but their magic lies in their simplicity. Imagine a neural network as a series of interconnected light bulbs. When you switch on the first bulb, it sends a signal to the next one, and so on, until the last bulb in the chain is lit. In essence, this is how neural networks function. At the heart of a neural network is a series of layers, each consisting of multiple nodes, or neurons. These layers are categorized into three types: the input layer, the hidden layers, and the output layer. The input layer receives the initial data, the hidden layers process it, and the output layer provides the final result. So where does the magic happen? It's in the hidden layers. This is where the neural network learns from the data it's given. Each node in these layers is like a little decision maker, processing the data from the previous layer, applying a weight, and passing it on to the next layer. The weight is just a fancy term for a value that determines the importance of the input. Through a process known as backpropagation, the neural network adjusts these weights based on the accuracy of its output. If the output is incorrect, the weights are tweaked to improve the result next time. It's like a child learning to ride a bike. They wobble, they fall, but each time they get back up, they adjust their balance a little better. But what makes neural networks truly special is their ability to recognize patterns. By analyzing vast amounts of data, they can identify hidden patterns and make predictions or decisions based on these patterns. For instance, a neural network might analyze thousands of dog photos to learn what a dog looks like, and then use that knowledge to identify dogs in new images. So, neural networks are like a sophisticated pattern recognizer, making sense of the data they are fed. Their ability to learn from mistakes, adapt, and predict is what makes them a powerful tool in the realm of artificial intelligence. You might be thinking, why should I care about neural networks? Well, let's dive into that question. Neural networks are like the backbone of artificial intelligence. They're the reason why AI can learn, adapt, and evolve. They are the systems that allow machines to think, learn, and make decisions, much like the human brain does. Without neural networks, AI would be as rigid and unchanging as a piece of code. Neural networks have a broad spectrum of applications that touch nearly every aspect of our lives. Let's take healthcare, for example. Neural networks are being used to diagnose diseases, predict patient outcomes, and even assist in surgeries. They analyze vast amounts of data, recognize patterns, and make predictions that can save lives. In the realm of finance, neural networks are used to predict market trends, analyze risk, and make investment decisions. They're able to sift through a mountain of financial data, recognize patterns that humans would miss, and provide insights that can lead to smarter financial decisions. And don't forget entertainment. Ever wondered how Netflix seems to know exactly what you want to watch? That's the work of neural networks. They analyze your viewing habits, compare them with millions of others, and recommend shows and movies that you're likely to enjoy. Neural networks are also crucial for the development of AI and machine learning. They're the structures that allow machines to learn from experience, adjust to new inputs, and perform tasks that would normally require human intelligence. They're the reason why we have self-driving cars, voice recognition systems, and personalized recommendation engines. They are the gears that keep the wheels of innovation turning, pushing us further into a future where machines can think, learn, and adapt. They're not just an interesting concept in computer science, they're a transformative force in our world. In short, neural networks matter because they are the cornerstone of AI, the driving force behind machine learning, and the key to unlocking a future where machines can think and learn like humans. The power of neural networks is transformative, reshaping the way we live and work. Now that we understand what neural networks are and why they matter, what does the future hold for them? There's no denying that the potential future developments of neural networks are vast and intriguing. As we continue to harness their power, we're likely to see them evolve in ways that will make them even more efficient and impactful. Just think about it. We're looking at a future where neural networks could enable truly autonomous vehicles, not just cars, but drones and even spaceships. They could help us create more advanced personal assistants, capable of understanding and predicting our needs better than ever. They could revolutionize healthcare, with neural network-powered systems that can diagnose diseases and suggest treatments with an accuracy that outshines even the most seasoned doctors. But this future is not without its challenges. As we push the boundaries of what neural networks can do, we also push the boundaries of what they can't. The complexity of these networks can lead to a lack of transparency, often referred to as the black box problem. This means that while a neural network can produce a result, understanding how it arrived at that result can be difficult. Another challenge is the need for vast amounts of data. Neural networks learn by analyzing data, and the more complex the task, the more data they need. However, gathering and storing this data can be expensive and raises privacy concerns. Then there's the issue of energy consumption. As neural networks become more complex, they require more computational power and therefore more energy. Finding ways to make them more energy efficient is a significant challenge that researchers are currently grappling with. Yet despite these hurdles, the future of neural networks is undeniably exciting. They are constantly evolving, learning, and improving. Every challenge they face is an opportunity for innovation, a chance to push the boundaries of what's possible. The future of neural networks is as exciting as it is uncertain. One thing is for sure, they are here to stay and will continue to shape our world in ways we can only imagine. So there you have it, neural networks, the brains behind the machine. We've embarked on quite a journey today, from the vast, intriguing world of artificial intelligence to the intricate design and function of neural networks. We've delved into the magic behind these networks, how they mirror the human brain in their ability to learn and adapt. We've also highlighted why these networks matter, how they're revolutionizing various industries and enhancing our daily lives. And we've looked to the future, imagining the endless potential of neural networks, from medical diagnosis to self-driving cars. It's clear that neural networks are not just a fascinating concept, but a transformative technology, shaping our world in ways we're only beginning to understand. The next time your phone predicts your text or a computer recognizes a face, remember, it's all thanks to the power of neural networks.